Number 27 says, two loudspeakers X and Y emit sound waves that are in phase and of wavelength 0.75. An observer O is able to stand anywhere on the straight line that passes through X and Y. So an observer O is able to stand anywhere on this straight line that passes through X and Y. So he can stand anywhere on this straight line, this observer. So the question then says, the observer stands at a point where the sound waves from X and Y meet in phase. So he stands where the waves from X and Y are meeting in phase. What could be the distance OY from O to Y? Sorry, from O to Y, yes, that distance here. And the distance XY, the distance from here to here. That's what the question is asking. Now, if the observer stands at a point where the waves are meeting in phase, then it must mean that where the waves are meeting, then the waves are meeting in constructive interference. So if they are meeting in constructive interference, then we want to know the distances. Then this question is more like a two-source interference question, where we want to know the path difference, we deal with path difference for constructive interference. Now we do know that path difference for constructive interference, because that's constructive interference, they are meeting in phase, so there's constructive interference. And remember that this statement here, he had said that the two loudspeakers emit sound that is in phase. So the sound is leaving Y, it's leaving X in phase. So it is arriving at the observer also in phase. So for this to happen, then the path difference has to be n lambda, where n can be 0, 1, 2, 3, 4, 5, continuously like that. Now we are given the wavelength now. So we are given the wavelength. So the wavelength we are given as 0.75. So the path difference, what is path difference, by the way? Path difference is the difference between the path taken by the wave which leaves X to reach Y and the one which leaves Y to reach O. Or maybe let me repeat again, I didn't say that correctly. The length of the path taken from Y to O minus the length of the path taken from X to O. When you subtract those lengths, that's what we call path difference, because those are the distances moved by the waves to reach point O, in which case they are meeting in phase. So now, first things first, what I would do is I will subtract these values. Now, just to humor you, it is obvious that OY, the distance from O to Y, cannot be less than the distance from X to Y, since O, it's not as obvious, but whatever the case, as long as this object is at this side, then the distance from O to Y cannot be less than the distance from X to Y. Of course, this object can occupy any position, even this position, so we cannot reach that conclusion as of yet. But what I can say is that we need to subtract the distances, the difference between XY and OY. Why do we need to subtract that one? Because we need ultimately to find the path difference. We want to see the path difference here, and I hope that you'll be very patient to listen to this. So let us start by saying, if the distance from O to Y is 1.25 and the distance from X to Y is 3.50, then our object will be in the center there. So if it is in the center there, if the distance from O to Y is 1.25, then the distance from X to O will be 3.50 minus 1.25, which will be, because from X to Y, remember, is 3.50 in A. So minus 1.25, that will give us, I think, 2.25. So 2.25 here. So So the distance moved by the wave from x to O will be 2.25. The distance moved from O to Y will be 1.25. So subtracting these distances moved by the waves from Y and from X, you get actually your answer as 1. Now 1 is the path difference, but dividing 1 by the wavelength of 0.75 will give us an answer which is not a whole number. So here we must be having n as a whole number, which can be 0, 1, 2, 3, 4, continuously like that. So this does not work. Then we go for the second one, which has a distance OY being 2 and the distance XY being 2.75. So in which case I believe that we can say that from O to Y, O might be here, so that this is 2, the distance from O to Y. And the other distance, if from X to Y is 2.75, then this one is 0.75. So the distance moved from X to O is 0.75. From Y to O is 2. So the path difference then will be 2 minus 0.75, which will give us 1.25. So if we have a path difference of 2.25 and divide it by 0.75, again, this does not give us a whole number. So if it does not give us a whole number, then we are not going to have a path difference which provide constructive interference, which is supposed to be n lambda. N, which we get by dividing the path difference and the wavelength, should be a whole number, which is 0, 1, 2, 3, 4, 5, continuously like that. So it's not a whole number here. So B is not correct also. So let's erase and continue. Then C is saying the distance from O to Y is 2.75. So in which case, if the distance from X to Y is 2, then what they're meaning is this one, the distance from here to here is 2. But the distance from O to Y is 2.75, meaning that O is somewhere at here, such that there's an additional 0.75. So there's an additional 0.75 to move from O to Y, so that the distance from O to Y is 2.75. So the wave moving from Y to O, we have to move a distance of 2.75, whilst the one moving from X to O, we have to move a distance of 0.75. So the path difference is between the one moving 2.75 and the one moving 0.75. This will give us 2. And 2, that's the path difference, divided by 0.75, the wavelength, it will not give us n, which is a whole number. So again, this cannot be. So just to prove that the last one is the correct one, I'll then say from the distance from O to Y, in this case is 3.75. So if it's 3.75, let's say where it is now is 3.75. So, and the distance from X to Y is 1.5. So if this is 1.5, but from O to Y is 3.25, then we could agree that the distance from X to O will be 1.75. So this will be 1.75. Okay, so the distance from Y, the distance moved by the wave from Y to O is 3.75, but the one from X to O is 1.75. So 3.75 multiplied by the minus the distance moved by the wave from X to O, which is 1.75. This will give us, I think, if I'm correct here, this will give us, sorry, this is 3.25, sorry, minus 1.75. This will give us 1.5 ultimately, divided by 0.75, this gives us 2. So it gives us a whole number, meaning that we have found a situation where n is 2, so n lambda will give us a path difference for constructive interference. So they meet in phase with respect to D.